Hey everybody, we are back with .NET Conf.
That's right. They fixed my volume, maybe.
I know, now I'm sitting next to you and it's just like blasting.
I'm trying to be super quiet, but I don't know how to do it.
You gotta use that NPR voice, man.
Hello and welcome to another episode of The Mating Sounds of African Swallows.
You know, are you okay there, Jeremy?
Sorry, that's what they talk about in NPR, right?
Yeah, we have, all joking aside, we have our next speaker, Jeremy Miller, talking about Marten and Document DB. How's it going, Jeremy?
That's going well, man. It's good to talk to you.
I know, it's been a while. So what's up? Let's see your code. Let's see your demos.
We ready to get started?
We're ready to get started.
All right. Somebody's at the end of a long day.
Yep. Go ahead and kick it off, man.
You ready, buddy?
All right. Is my slide deck showing?
Yeah, it looks good.
We see everything, man.
Yep.
Oh, okay. All right, good. Well, I won't share this at all, but if we ever see each other in person, I had a really terrible incident trying to use the European African swallows example from Monty Python in a talk one day. But
You can't just drop
So
that,
off we
man,
go.
and leave it there.
no, because it's a little too profane.
Okay.
So today we're going to be talking about a project called Marten, and that's spelled with an E, because what it really refers to, and here I didn't think to pull a picture of it, but everybody, we got to see how cute these guys are first. So Marten is actually not named after a person, is named after these cute little boogers I'm about to show on the screen in just a second. Yeah, these guys. See how cute that guy is? So that's what Marten's actually named after, not a person. So Marten is a client library. It's a .NET distributed as a .NET NuGet that allows you to treat the Postgresql database as both a document database and an event store inside of a .NET application. Now, next we'll go into why in the world did we think this was a good idea, and why might you be interested in trying to get some of this? It's a little bit of a funky idea, but let's get into it. So first off, at the end of this, if you're still not scared away, we've got quite a bit of community around this. We're up to almost 80 contributors so far. We've got a lot of documentation and samples up on our website. We always find something that's missing, but we've tried. The code itself is up on GitHub. It's under an MIT license, so you can pull it down, copy it, make fun of it, take whatever you want out of it. And then finally, I'm a huge fan of Gitter for having an embedded chat room for attached real closely to your GitHub repository, and that's the best place to go ask questions about Marten. All right, so just a little bit of a history. So about the 2014-2015 timeframe, at a former employer, my colleague Corey Kaler and I were kind of talking, and he had the idea that, hey, we use RavenDB very heavily, and we love the development experience, but we were having some trouble with it in production scenarios. And it was getting to the point where we knew we had to replace it one way or another, but RavenDB's usage is very different than what you would get from many other persistence frameworks or databases. So we kicked around the idea. Corey actually had the idea. I'll give him credit. What if we could take PostgreSQL? Hey, it's got some pretty cool JSON support. What if we could turn that and make it act just like RavenDB, and we could swap it in and out? So from that conversation and a whole lot of time later, Marten itself was born. As kind of an add-on that's actually turned into maybe the most popular feature of Marten, we also looked at adding event sourcing support in the library with an eye towards replacing very, very old versions in Event Store in our shop. So we got to roll out It finally went 1.0 in September of 2016. It had actually been in production, in a very large production app, quite a few months before that. 2.0 came out last summer with a lot of improvements in the internals, a lot of work to reduce memory allocations, and generally make everything as efficient as we can possibly make it. There is a 3.0 that's in progress, but it's not progressing super fast. And I'm not going to demo any new features here today. But it's coming. So I want to talk about some of the very different ways you can do application persistence to kind of look at where Marten might fit in. So most of my career, we've used just old-fashioned relational databases. Maybe we put other stuff on top of it. Maybe we put ORMs. Maybe we put other tools like this Marten thing. But tables, rows, foreign keys, primary keys, views, stored procedures, God help us, the kind of stuff we've always had. Now, some of those tools, I don't necessarily like it for a lot of transactional applications, but SQL is awfully hard to beat for reporting. And there's a whole lot of investment that we probably all have in reporting tools and learning SQL and all the third-party stuff that already supports database binding. So there's plenty of good reasons to keep relational databases around. What we'll mostly be talking about in this talk is using a document database. Huge advantages for developer productivity, in my opinion. Other cases, you might use event sourcing, where I don't store the exact state of the current system. My system of record, I may be storing events as they happen. It's like in an invoicing system, an invoice was created, an invoice was approved, so on and so forth. And from that raw event data that may be valuable in itself, off to the side, we calculate and create a read side current state of the world. Addressing the relational models, various kinds of ORMs. Maybe we use Entity Framework, maybe we use something lighter like Dapper. Now, the cool thing about Marten here is that it allows you to mix and match any of these tools. Marten itself supports the document database and event sourcing, but at the same time, because it's sitting on top of a relational database, you can happily use anything that Postgres offers. You can happily use an ORM with it, and we have specific integration with Dapper. Not that that really means much. We just expose the connection so you can use a Dapper with it to your heart's content. So you're not stuck with just Marten. You're able to choose whatever persistence pattern makes sense for a particular feature within the same application. And that may be very advantageous to be able to switch like that even inside of one single system. Okay. So if you're not familiar with any kind of NoSQL system or specifically a document database, why you would care about it, what it does for you. If you think about using an ORM today, that's probably the most common pattern. You're spending a little bit and maybe a lot of time doing mapping. Where does an object model property land in a database field? Hopefully, the database and the object model looks alike, but a lot of times they really shouldn't, and it makes it a little harder for you to try to do those mappings. Maybe you have object hierarchies that don't fit the database well. Maybe you have deep, complex objects where you have to start to span a lot of different tables to make it work in a relational model. Document database is really nice, especially when you get into hierarchical models. You're not mapping the structure. What we're doing, and especially with Marten, you're just serializing your objects to JSON and stuffing it into a single column in the database. Right? Your schema is your objects. So some of the great things it does for you, the advantages it gives us as developers, it's a whole lot less mechanical work to make things happen. Not spending any time with JSON. I'm not creating two completely separate models, a storage model and a model for my business logic. I just worry about what the document structure is like in C#, make sure that the inevitable ubiquitous Newtonsoft.json can serialize it, and I'm good to go. This is absolutely perfect inside of an agile development process. As much as possible to make agile go, it needs to be really easy to make design changes. You pay a penalty anytime there's extra cost for changing code. So taking the example of adding a field and going all the way from adding it to your object, adding a field to the database table, adding a database migration, so on and so forth. A document database, at development time, as we'll see with Marten, you wouldn't have to do a thing. Add a new property to your document, and you are off and running. There's no extra work to touch your database. We get much less friction from making additional changes to our objects. It allows us to play with design ideas because we can adapt to the database very quickly. There are some database migrations. We are still running in PostgreSQL. We do still have to manage the database schema, but it's just that the database schema is going to change much, much less often. This last bullet point, this is actually a big deal. So the trend I've seen the last several years, software development and the way we approach automated testing, it's shifted much more towards trying to incorporate much more integration testing, at least intermediate level testing. And it means going all the way through the database, as opposed to trying so hard to isolate things and making code more complex just to be able to get unit tests without the database. So if you take that idea that integration testing is a good thing, we always have to make sure that we have either a clean or a known state in our database before we test through it. The document database actually makes this a lot easier, especially with something like Marten or what we did previously with Raven. You can effectively do a complete wipe of the database with a single command in Marten before any kind of automated tests. It makes it very easy to effectively provision a brand new database schema per test. Right? If you've done any work with relational databases inside of automated tests, that can be a lot more complicated. Relational integrity, making sure you delete things, tables in the right way, it's just a lot of extra work and it's potentially pretty slow. All right, so why PostgreSQL? And let me get this one out of the way fast, because every time I've given this talk, somebody asks. The logical question is, why did you not use SQL Server? This is a .NET tool. Most .NET shops want to use SQL Server. They're more familiar with it. And we'll be honest, we know that Marten would probably have much more adoption if we'd been able to use SQL Server. So our belief is that Marten is using a lot of features that are very specific to PostgreSQL around its JSON support, its embedded JavaScript support, a lot of JSON operators that are unique to PostgreSQL itself. We think long-term that not the current version of SQL Server, but the next version of Postgres, version 11, and hopefully whatever the next version of SQL Server, that SQL Server will reach enough parity, and both of them will support a SQL/JSON spec that kind of standardizes how you address the JSON data inside the database with JSON path. That would make it a lot more possible, or a lot easier for us to finally make Marten database agnostic. But for right now, Postgres is pretty awesome. It's super easy to install. It's really lightweight. All the examples we're going to show today are actually running in Docker. Because it's super lightweight, it's really easy to bring down a Docker image and get going. It's been around a long time. It's over 20 years old. It has a very active community, and they're innovating very hard and very fast. But specifically for Marten, it has a lot of really unusual JSON features. The JSON itself is stored in a special column type called JSONB that is a binary representation of the JSON document, which enables Postgres to reach into the JSON documents much more easily and much more efficiently. Okay. Part of our original goals with building Marten was we also needed to get onto something with that kind of usability, but we need to have grown-up DevOps tools. We need to have good monitoring tools, backup tools, all those kinds of things you have to have in a grown-up shop. And by being right on top of PostgreSQL, we get to have everything the Postgres ecosystem has. All right. So let me catch my breath for a second, and we're going to actually look at code finally. So getting started with Marten. Now, let's assume we're building some kind of order management system, and a really simple one at that. So let's say we have a very simple C# class, like this order class that's on the screen. The order class itself may have one or many order details, and you see that I'm using a custom enumeration for the priority. As quickly as possible, we want to get this spun up where we can persist and load these little order classes with Marten. So, first thing I want to do, need to create a document store for Marten. And in this case, we're not customizing anything. We're not configuring anything. We can go with all the default options. So the only thing I need to do is just say, I want a document store for this connection string. And right now, this is pointing to an instance of Postgres let me double check this. You'll see over on the right. Oh, sorry, let me go ahead and clean this off. Let me go wipe this out. As I said very much earlier, we have just a little handy helper that will allow you to completely clean off your database schema and start over. And that's what I did here with the code that's highlighted. Looking in the right of our IDE, now there's no tables at all in our public schema. Just out of curiosity, for anybody who's wondering, if you've never seen this before, I'm using JetBrains Writer for all the demos today. Just giving JetBrains a big shout out. They have been very generous. I have an OSS license from them, and Marten's pretty well supported and built now, at least from my side, with JetBrains Writer. So we have no database, but we have an order class, and we'd really like to get it persisted. So we have a store. So that is going to be a singleton object within your system. There's not a direct analog inside of Entity Framework, but if you're familiar with Hibernate, I'd say that's roughly analogous to the iSession factory from Hibernate. So, but to get to Marten's version of a DB context, we need to get added an iDocuments session. And that's what's happening in this method right here. So the document session represents a unit of work to Marten. So it allows you to establish transactional boundaries, and it exposes everything you would possibly need to query a Marten data store. In this particular case, we're going to create an order object. And we'll notice here, I'll come back to this, at no point do we actually set a value for the ID here. As you can probably guess, the ID property, that's going to end up being the primary key in the database. But getting back to it, so we're going to create a session. We're going to tell the session that, hey, I want to store this order document. Save changes here. This is committing any of the queued up changes to the database, whether it's updates, inserts. The store here is a generic upsert, meaning that it updates the document if it exists or it creates a brand new one. And there's several other kind of operations, but it flushes all the changes in as much as possible in one command to the database. Below that, we'll go fetch a completely separate session just to make sure we're not getting any kind of cache copy from this one. And we'll try to load the order back from the ID that's been magically assigned and just prove that it's all there. So I'm going to run the test here. Okay. We succeeded down here. So a couple things. Marten, just by convention, if it sees a property called ID, it assumes that's the identity for your object. There's some ways to override that, but going with all the defaults and just working with it idiomatically the way it wants to, It knows that ID is our primary key, and because it's a GUID, if you try to store it with an empty GUID, it'll just quietly make a new GUID for you and assign it to the document itself before it persists it. For those of you who are a little more familiar with it, it is a sequential GUID so that it saves and loads quite a bit more efficiently to the database. And right off the bat, we've been able to load that order by its ID. We've done no mapping. We've done no configuration, just to prove that stuff actually exists. Let's take a peek in the database. So on the fly, we created an order object or an order table that stores it. There's not a lot of stuff going on. Most of your document tables are going to look exactly alike. It's going to have an ID column of some kind. It's going to have a data column that actually has the raw data and a little bit of metadata, the kind of things you would expect, last modified, other stuff like that. Let's take a peek. Just a second, just to show you what the data looks like. And the joys of coding live. Yeah, so there's a JSON body. Woohoo! So not super exciting, but that's a good thing. We didn't have to have any drama. We didn't have to do a lot of configuration. We added the Marten NuGet reference, and we created a document store for the connection string. Because I'm using all the defaults, this is running in a development mode, meaning that it will create any necessary tables it needs to on the fly if they don't already exist in the database. So this is our getting started story, trying to make it as easy as possible for new people to pop up and start doing things. Now, show off the advantage of where a document database excels. Let's change our order object and see what we have to do. So now, let's say the order has some kind of address. Maybe it's a billing address. Who knows what it is? So I have just another little type here. And you'll notice there is no ID on this. We don't have to. The address, when it's persisted as a property of the order, it's going to be persisted directly in the order. I don't have to create other tables. I don't have to think about anything else. To come back into this test, let's go ahead and add. I'm not going to fill out the whole test, but just add a little bit of data. So hello from Austin. And now let's persist the whole shebang. Let's run one quick thing here. Just to show what the JavaScript's going to look like. All right, so we're going to do the same thing. We're going to save the address. We're going to save the order, except now it has an address property. We're going to load the thing back up, and I'm going to try to spit the JSON out into the test output. If you look at the bottom right of the screen, okay, we've already come back, and look, there's our new billing address. Again, no mappings. We had to do no mappings. It just worked. All right. So let's move on to some of the cooler things with Marten. So most of you, if you have no background with NoSQL or only a little background with NoSQL, you're kind of wondering, why am I making a big deal here in this slide that Marten, and really just Postgres underneath it, is completely ACID compliant. This is something you've always had in relational databases. This is something you always expect to have. You can't believe people try to do without this. But a lot of the NoSQL databases, and probably especially the early NoSQL databases, were not ACID compliant. Most of them had some kind of eventual consistency where writes happened immediately, but you were not necessarily able to immediately read or query over the state. There'd be a little bit of gap when the reads were not in sync with the state of the database. And this was a huge deal for us as we moved from my previous shop. We moved from RavenDB to Marten. It was something we knew we wanted. So just to prove this, we find the next database sample. All right. Now, what we're going to do is have a fat object that we use to test Marten, just called target. This has a lot of fake values to have every type we can possibly think of. We have GUIDs, we have longs, doubles, dates, we have children, grandchildren, just trying to be big. We're gonna throw 1,000 of these into the database as fast as we can. So we got here, and then as fast as we can, we're gonna come back and we're gonna query that we can pick out how many of these are green. Just to prove that we can immediately query against the data we just inserted. Just run these real quick. And we look here, super fast here. We get an all new database session. So if you look at the bottom left, the spinning ball, we got the green check mark, it just worked. So there's nothing you have to do here. This is actually pretty rare for a NoSQL approach. This ability to immediately query against the data that was just inserted without any kind of eventual consistency catching up on the read state. That's a huge deal. We get all the goodness of a document database and NoSQL kind of approach, but we didn't have to lose out on ACID compliance that we get from good old-fashioned relational databases. Getting into some other ideas, maybe where a document database shines over the ORM approaches you may be used to today. If you think about having some kind of object hierarchy, and in the case we're going to get into for this example, let me get to where I want to be. So we have our order, the way that we've had. This isn't a very fancy example. We have an order, but maybe we have specific kinds of orders, domestic order, international order, and maybe they actually have some different properties. Different properties, different values, different behavior when you pull them down. When we work against the persistence, sometimes we want to see all the orders together. I want to see all the domestic and international orders for a certain part. I want to treat it as just an order. But other times, I want to load a specific type of part. I want to load an international order or a domestic order. I want to use link queries against either the subtype or the parent type. Okay? This is something Marten supports out of the box, not nearly as much effort that you would have with an object, with an ORM. I don't have to think about, do I have a separate table per type? Do I try to put them all in the same type? Do I have like extension properties in a very sparse table? How do I map that? Forget all that stuff. Marten's going to take care of most of it for us. One thing we do have to do, though, is we just have to tell Marten, for the order class, I want you to also include the specific subclasses for domestic order and international order. Now, coming down into usage, just showing here, I can create a domestic order. I can put all the properties in I want. I can create an international order. And we just added something on the fly. because I think we were making fun of Hadi from JetBrains earlier today on Twitter for something. Let's say it's going to Spain. And I can store one, I can store two, save them both. And I can come back and I can load them as an order, or I can load them specifically as the subclass. I can query any possibly mixed match here. Looking at the bottom left, just to make sure the test passes, and there it does. Just a cutesy little thing, this last one here. So I want to query a domestic order where the customer ID is somebody. And all I'm doing is, Marten has a little helper that will allow you to preview what the SQL command is for a link query. So I'm using that just to grab the SQL to be generated. Bottom right, you just see we're looking over this ugly table name, and I am limiting the query to, well, this is Martinese for I only want domestic orders. That's part of the SQL where clause. All right. So that's the basics. Saving and loading documents, just to JSON. If this is all there was to it, you could probably code this up by yourself, honestly, pretty fast, except for the link query part. Just to bust everybody's bubble, the link query part is super work intensive, really monotonous. And if you like the link provider and whatever database tool you use, give some positive thoughts and thank yous to whoever wrote that, because it's miserably time consuming. But so some of the things we've done to try to make Marten fast on top of that. We have computed indexes. It's perfectly possible, and we were tipped off to this by some Postgres gurus. We can define computed indexes inside of our JSON document. I'll show an example of that in just a second. Oh, now let's look at it now. So that's actually what we're doing here. In that example where we wanted to throw a whole bunch of records in really, really fast and then query against them. So the code that's highlighted there, that's actually just telling Marten, hey, I want an index against the color property of target. If you're familiar with EF Core and the way it does mappings or something like AutoMapper, you're used to using these kind of expressions as a strong typed way of saying this property, this type, so on and so forth. And that's what we're doing here. There's a little more power here to say, do I want this to be unique? Do I want it to use all the special features and types of indexes in Postgres? But it's probably what you want to do. So when I'm issuing a query now down below where I want to look for where the color property is green, Postgres is able to apply that index just like you would with a relational database when you set a query on a column that you frequently search over. All the same problems as database indexes that always exist. You always have to wonder, is this creating more overhead on inserts than it gives us in value on speeding up reads? Same rules apply. The bigger one, and the speeds, some of the other things we do. Out of the box, our default JSON serializer is newtonsoft.json. It's the obvious choice as the default because it's the most battle tested. It works for everything. Some weird things still leak through, especially some oddball things like F# types, or we've had a couple people wanting to query against nota time objects that kind of give us some trouble with the JSON serialization, but it's rock solid. But if you want to, we've been able to swap out and use Jill as a faster serializer or some of the newer JSON serializer alternatives. So you can opt into maybe and get some better performance by going to a different JSON serializer and still use it with everything that Marten does. Actually had a little bit of conversation with a trainer in Houston that I had sat in on his VB6 classes 20 years ago, and he had this phrase that stuck with me ever since. Network round trips are evil. Fastest way to make your enterprise system really, really slow is to be really chatty, making a lot of consecutive calls to the database to get a little bit of information. When developing Marten, we were trying to be very cognizant of that, and we've tried to minimize the number of batch query or the number of round trips to the database as possible. When you're committing a document session, it's trying to send the commands all in one network round trip. Same thing with queries. I don't have an example in this talk, but you can set up multiple queries, like if you need to get at one document type and another, and grab them all at one time. So try to minimize the number of round trips. Excuse me. The feature that I'm most proud of, we call it compiled queries. And it's faster just to show an example on this one. So take a look at this find by color class that I have highlighted here. So that same query we've been doing where I want to just find all the targets where its color is green. And that's what we're expressing here by this find by color class. And it looks a little funky. You're definitely going to be dependent upon ReSharper or CodeRush or something like that to generate the signatures for you from this interface. But let me try to explain why this thing is so cool. Let's take a look at how it's used. So instead of using a link query directly, I'm going to use the sessions query. There's an overload that will allow you to pass in one of these compiled queries. So I'll create that object, pass it in here, and it basically does the same thing as if this is the equivalent of same equivalent as just writing out so this is actually the equivalent of that. So why this is so awesome, even though it looks really funky. The mechanics of doing queries by link are super duper inefficient. So just thinking about all the things that happen when you issue a link query. You're creating a whole bunch of little objects. It may not feel like it, but you're creating a lot of objects in that little expression where you do the where clause. So when you pass the link query in, your link provider has to take all these little objects, and this is probably more fun if you could see all the goofy hand motions I'm doing, but it's got to walk down this tree and this really excruciatingly low-level detailed model of what are all the expressions. There's an and here, an or here, what property is. It's got to parse through all that stuff, figure out what's going on, interpret all that object model, then do a bunch of string concatenation, come up with a SQL command, and then figure out how the data combined ends up going to an object model, and so on and so forth. It's a lot of mechanical work to interpret a link expression and do something useful with it. The compiled query feature in Marten, it allows Marten to remember the query plan for a link statement, so that the first time in the application when I use this find by query model, it's effectively parsing and interpreting the link expression one time, and then it's remembering the SQL statement and how to map from the parameters on our compiled query into what the raw database command is, and then also it remembers how to go from the results of the query to returning the object models that you want. We found in our testing it's consistently seen better than an order of magnitude improvement in querying speed if you use a compiled query versus just using raw link. So we're really proud of it. And that's why I spent so much time talking about it. Just talking about some other things that are in there. If this is a pretty common feature, the includes, just the idea of if I have one document and it's related to another document type, I can actually force Marten to go fetch them in the same network round trip. Again, network round trips are evil. We can opt into Postgres support for bulk inserts. So you can, if you get into a case where you need to jam in a whole lot of documents all at once for some reason, you have this bulk insert command that will opt into Postgres's more performant mechanism for doing bulk imports of data. And finally, and especially if you come from the MongoDB world, we have the ability in the, we have something we call the patching API, where instead of trying to download the whole document, putting it into a .NET object, changing it and sending it back, you could just say, I want to change the property within the document in the database to this value. It actually takes a lot of advantage of JavaScript functionality, a JavaScript function running inside of Postgres to make that happen. All right, getting close to the end. Just some other special features, and this will be much better supported into Marten 3.0, whenever that happens. So the documents are stored in JSON in the database. In some cases, Newtonsoft might have to put some ugly .NET serialization stuff in there for type information, but most of the time that JSON is pretty clean. It may be perfectly possible to just take the raw JSON and go grab it, because Marten will let you just get the JSON string and immediately toss it down an HTTP response for really efficient HTTP web services. You know, some of you are saying, oh, but you know, you're never supposed to put your object model across the wire, which is true an awful lot of the time. So along those lines, so rather than pulling in your object and using something like AutoMapper to translate it to a totally different view model and serialize that down your HTTP response, what you can do instead is use a JavaScript function that takes the raw JSON of your model and changes it into the representation that you want to go out of the response in your own web service. And you can let Postgres run the JavaScript in the database, so you never really create any objects or do any kind of serialization in your web API. This for Marten 3.0, we want to go a little bit farther. Today, you have to create a JSON string to pull this off, which it's still some object allocations. In Marten 3.0, we're looking at a model where you could just basically stream the bytes, the raw bytes from the Postgres world directly into the HTTP response without even having to allocate a string. Looking for just the absolute fastest possible way to have web services that just deliver data out of the database. But that is yet to come. So the last feature, and it is a big one, last feature I want to talk about is just shifting over a little bit and looking at how Marten can be used for event sourcing with its full-blown projection support. So like let me back up. So hopefully when you look at Marten's event sourcing, it looks pretty familiar. And one of the reasons it should be pretty familiar if you've used any other event sourcing tool in the .NET world is we all pretty well started by reading Greg Young's seminal paper on event sourcing and kind of going from there. So in the case of Marten, just like Git Event Store or In Event Store or several other tools, we have really two concepts. We have events and streams. And all a stream means is some kind of related group of events. So moving into the example I have today. Grew up in the kind of in the middle of nowhere. Wasn't a ton of kids to well, there really wasn't any kids around to play with. So kind of naturally became very bookish and read way too many epic fantasy novels, whether it's Lord of the Rings, Wheel of Time, Game of Thrones, hundreds of others. But so let's model that. Let's say we're building a system to track the progress of a party carrying out some kind of quest in an epic novel. So maybe it's Frodo and Samwise heading off with all their companions, going to throw the ring in the volcano, or I'm actually going to use the Wheel of Time as our heroes leave their little village and go out into the big world. But so the kinds of things that happen to a quest party as they go out in the world, we have events where members show up and join the party. Maybe at other times, Sam and Frodo take the boat and go off on their own, and everybody else leaves. People leave the party. They get to certain destinations. Maybe they slay monsters, whatever it's going to be. So with event sourcing, we don't have a master document of what's the state of the quest party. We're tracking all these events. Members joined, arrived at a location. When did the quest start? When is it done? Who left? I don't know what that's there for. In real life, the canonical example I think I see more than anything is invoicing orders. An invoice, somebody filled out an invoice. Then maybe you added an item. Finally, it's approved. The invoice was paid, tracking those kinds of events. So in our case, let's start out. We're going to create a new quest, and we're going to record just a couple events at a time. It started on, maybe we'd record what day it is, but we're going to say the name of our quest started. We're going to add some members. So these guys started out and on day 1. And then also at day 5, this guy, Tom, he ran off. So I'm going to create the same kind of session from the store, document session, because all this is exposed there. Everything is off, a property called events. Just show some of the things it does. That was more complicated than I was expecting it to be. Okay, never mind. That was scary. One of the things I can do is I can say, all right, I'm going to start a brand new stream of events, and I'm going to specify what the stream ID is right here. I can let Martin do this, but we're going to specifically say it's this particular quit. And then I'm just going to tag on these events to it. Save my changes. Events, part of the same unit of work. You can mix and match persisting events or appending events to a stream with saving documents. And that comes into play in a minute when we talk about projections. Coming down the line, let's say we pick up a couple new team members on, say, day 7. We pick up these extra characters, and we can append them to the same stream of events. So we could be tracking multiple quests. We could be tracking the Lord of the Rings. We could be tracking the Wheel of Time, the Belgariad, whatever epic fantasy book you loved as a kid, but keeping straight what party is doing what at what time. So that's tracking the raw data. And I think most people that get hung up on event sourcing, or at least my initial reaction is, well, persisting the events, that sounds pretty easy. You know, especially in our case, we have one table and we're persisting an ID, maybe a timestamp, maybe an order, and JSON, XML, some kind of serialization of the events. That's great. How do we work with that data? Because sooner or later, we need to see what is the current state of the system. Some kind of what the CQRS folks will talk about as the read side model of the view. So event sourcing may be directly connected to your event sourcing tool. Maybe it's an add-on. You have an idea of projected views. Taking the raw event data and putting them together and trying to come up with what is the state of the system. Let me just look at another guy called Quest Party. So real simplistically, let's say that what we care about is the name of a quest, its stream identity, and just tracking who's part of our quest party right now. You know, if I ask you right now, who's in the party? And that's just the state here. But we derive this by looking at the raw data of like events like members joined, members departed, quest started, all this kind of thing. So at some point, we want to calculate from the events, we want to calculate and build up the state of this thing. And the code you see highlighted, it's not the only way to do this in Marten, but for very simple aggregate projections, one way to do this is just have an apply method for every event every event type that would apply to what you're trying to project out. Now, timing wise, that's something I think is a little bit unique to Marten's event sourcing, but I think everybody should get around to supporting it. These projections can be defined with 3 different time frames. I can either do it live, which means if I get into a case where I have lots and lots of event rights, but I very, very rarely do I ever try to read what the exact state of the world is, I might decide that the best thing to do is I'm just going to do the aggregation completely on the fly. When I ask for it, and only then and there will I try to see what the state is. So the example right here, that's what we're showing. I want to reach in at this time. So the started.id, that's actually defining what my quest ID is. Let me make that a little more clear. Except let me call it quest ID. So if I know what my stream identity is, my quest party ID, just ask it on the fly, go load up all the events, run it through the aggregation, and tell me what you get out at the end. That's what we're going to see up here. So we should see our members should be Rand, Matt, Perrin, Tom left, so he should be subtracted, Moraine, and Lan. We run the test as always. We're going to look at the results. We should see some JSON in the bottom right, please. Okay. And there are members. And there's also the name of the quest. So that's doing it live. So again, the recommendation there is maybe you do that when you have lots of writes. So you want to optimize how fast can you write the data into the system. So you don't want to be calculating anything. You just want to capture it as fast as you can and just occasionally read the state. And it's not that big a deal to wait a little bit to create the read side. Other thing that's maybe a little bit unique to Marten, what we can now say is, let's say the quest party, I want that updated as you capture the events. So that's what we call an inline projection. So with quest party, now I'm going to do just a little bit of extra configuration with Marten. I'm going to say, I want the quest party to be aggregated inline. Just meaning that when we capture any events that are related to quest party, I want that quest party projection value updated as part of the same unit of work. What that means is when I try to commit my unit of work, it is going to apply the new events to the event table, plus the newly updated read side document that is all going to go inside of one database transaction. So at no point can you have any inconsistency between the raw and the read side view. Let's just see if the test for this. It's not super exciting because it's doing the same thing, just a little bit different timing. Okay. So some of the purists in the audience are probably going to get a little bit freaked out about this. Some people believe this is a really bad idea, but what we found with Marten users, if you have an aggregate that where you feel like there is very little chance of there being multiple sessions hitting the same aggregated stream at the same time, you may prefer to go about it this way and just update your projected values per stream completely in line. So you never have to worry about any kind of eventual consistency problems. But that gets us right to the third approach, and this is probably the most common way that people do projections and event sourcing, is you have some kind of background process that's reading through all the events coming through, and it's trying to keep up and updating the projections as it can. So you commit the events, it's persistent to the database, the background process is listening for all the events coming in, and a little bit later, you've got an eventual consistency thing going on. So this is the only place where Marten isn't purely ACID. It's going to get around to updating the read side model for you. So with the price of the eventual consistency and the potential for making mistakes by showing data before something's processed, if you're concerned that you're doing a lot of aggregation across streams or aggregation where it's very likely you're going to get session contention on the projected values, which is pretty easy to do. Let's say that in our quest party system, we want to have a completely separate view of how many monsters have been slain at any one time. So in that case, every event across every possible stream that involves slaying a monster would have to fetch that one system-wide aggregate document, change it, and commit it. So you would have a tremendous amount of collisions. What we can do is we can switch to an asynchronous model for our projections for just that kind of view. Make sure I have an example of that. So we have a feature in Marten we call the async daemon. That is a little bit of Linux envy on my part, calling it a daemon, where I can set up, make sure we do this. So I can throw a bunch of events in, but I can create this long-running daemon. It's going to sit in memory. It's heavily utilizing TPL data flow to be consistent. There's a lot more complexity in here than it sounds, but it's constantly polling the database to see if there are new events that it cares about that are referenced in some kind of projection that are part of the async daemon. And it's trying to make sure that it hangs around and applies everything in the exact same order. So it's running in the background, trying to update these aggregated documents. Performance-wise, it might give you a big boost if you're frequently updating the same aggregate document. Just by the normal unit of work mechanics, it's able to hold on to the projected data views in memory and update in memories as it's updating things. But this is the only possible way you can really go about doing a projection when you have a lot of contention. I should say, didn't get into this enough, but the projected documents. So the reason why I think it actually made sense to add an event sourcing feature right onto Marten, the projected read side documents, they're just Marten documents. So you can query them, you can load them by ID, you can query them with any part of the link provider, you can do anything you want. We think that the easy integration management system, read side projected documents with the raw event data capture, it is a huge feature and a win for Marten versus other solutions where you may have to piece together, a raw event store, which may be saving its data to a completely different data store versus some kind of unrelated projection tool, putting your read side in some completely other way. Not everybody's going to agree with that, but many of our users on Marten that enjoy the event sourcing support, that's one of the big features and the key wins for Marten for them. With that, I'm not exactly sure of the timing because we got started maybe a minute late.
We're
But
right
Javier, that's
we're right on time, Jeremy. Just I figured we started late.
Woo-hoo!
It got pushed around, so it's all good from here. Thank you, Jeremy, for taking the time to talk to us in .NET Conf. There's some questions out on the Twitch channel. To keep on par with the schedule, we're gonna. I ask you if you can jump over there and we can answer those questions. You and I can kind of tag team them. We have our speakers here, and we're gonna get ready to roll. So we're gonna jump into a quick commercial, and we'll be ready with more .NET Conf. Again, Jeremy, thank you so much.